Hello students, how are you? I hope all of you are well and doing good. So, good morning to all. Good morning, good morning, good morning. My dear student, good morning and welcome to this session. Welcome to this session. Welcome, very welcome to this session. Yes. I hope my audio is clear to all. Now let's wait for other students, right? And then we will start our session. Now I'm doing one thing. What I'm doing, whatever be the extra question, 2, 3, 4 extra question, what I will do, I will include in my notes, right? From the app, you can download the notes and you will get the extra question, right? You can get that extra question. So I hope you are getting the things because from since morning 8 a.m. you are getting amazing lecture by Amit Dixit sir, right? Lecture by Amit Dixit sir, okay, in industrial engineering. Wow, he's a very very genius person. Okay, then after 8 to 9, I think 8 to 9, 10:30. You will attend. You are going to attend my lecture. Although it's a practice session, don't worry. It's a practice session, so it's a beneficial for those students who have completed their Who have completed their theory. Then from 4 to 6, again amazing session by Vishwajit sir. Okay, today he is going to teach what? Gear and gear traits. On the question, I mean he will take a question because it's a Abhyas batch now. In Abhyas batch, he is going to take a question. Calculation mat karna sir, फिर सारे question solve हो जाएंगे. Beta, I have to do the calculation now. Then after, some question I have to solve now because I have to discuss some concepts. Then in evening from 9 to 11:30, again amazing session is going to be done by taken by what? By Swadesh Singh sir. Okay, material science. So shall we start our session? Shall we start our session? Yes or no? Tell me. Because all of you are there. All of you are there. Shall we start our session? Yes or no? Yes or no? Shall we start our session? Are you ready? My dear student, are you ready or not? Are you ready? Yes or not? Tell me. Are you ready? Yes or not? Okay, I'm going to start this session. I'm going to start this session with a very beautiful line. Prepare solved question data. Okay, I'm going to start this session with a very beautiful line by APJ Abdul Kalam. He said one thing. You cannot change your future. You cannot change your future, but you can change your habit. And surely, believe me, and I also believe, and surely your habits will change your future. So it doesn't matter how good or how bad you are in your study. First of all, try to change your bad habits. Automatically, you will change your future. Are you getting my point? Are you getting my point? Yes or no? Tell me. Are you getting my point? Okay. Now, let's start this session with the first question. Now, tell me the answer. Yes, this is the first question. Try to solve it. For a metal alloy, which one of the following description relates to the stress relief annealing process? Yes. Consistent study and problem practice must be our new habit from now on. Wow! A very beautiful line said by Animesh Nanda. Animesh Nanda says that consistent study and problem practice Must be our new habit. Must be your new habit. It must be your new habit. Okay. So that you can change your future, right? Somebody says that option A is correct. Somebody says that option B is correct. Still there is a doubt. Still there is a doubt. Still there is a doubt. A, B, A, B, A, B. None of them correctly say the right answer. None of them. Right? None of them. Somebody say option A. Somebody say option B. Shall I explain? Shall I explain this question? Answer B is the correct one. Among them, answer B is the correct one. Among them, answer B is the correct one. Now, let me explain, my dear student. Let me explain. What is option A? It is clear that you are confused. In A and B. Right. So, I am going to discuss only option A and only option B. Right. So, I am going to discuss only option A and B because all of you have given either A or either B. So, you have a doubt in only both two options. So, let me discuss option A. What says option A? My dear, heating the workpiece material above its recrystallization temperature, okay, soaking and then cooling in still air. My dear, if you do a heating of workpiece above a recrystallization temperature, my dear, above a recrystallization temperature, right? Suppose that this is a temperature axis. This is a temperature. This is a temperature axis. And suppose that this is a recrystallization temperature. Okay. If you put a hardened workpiece below Rx, then there will be no stress relief. Okay. But if you heat the workpiece just below, or if you keep that workpiece just below or on at Rx, just below or on it just Rx, and you keep that workpiece in the furnace temperature, then what happen with that time? The new grain start forming. The new grain slowly start forming. They release their energy and new grain start forming. Right. So all of a sudden you cannot put into some liquid. You have to put that workpiece at Rx or just below Rx at a particular place. Are you getting my point? So what will be the answer of question number 1? That is B. Heating the workpiece material below or just at recrystallization temperature, holding for some time and then furnace cooling. Is that clear? And everybody? Is that clear to everybody? Yes or no? It's a very good question. What do you mean by recrystallization temperature? If you place a workpiece above recrystallization temperature, then grain growth will be happen. We have to just release the stresses. We don't want to make our workpiece soft. We want to just relieve the stresses. For that, you just place your workpiece at Rx or just below the Rx. Okay, in the furnace temperature, your stresses are going to relieve. Why? Because new grain produces. And these new grains are what? These are energy less. Because whatever the energy you stored in the workpiece by plastic deformation, that energy is going to what? Releases. But sir, recovery and grain growth will be happen above. Yes, recovery and grain growth will be happen. We are talking about just Rx or just below Rx. Yes, you are saying You are saying right that recovery will be happen if you put above the Rx. But I am talking about Shubham Pandey. I am talking about Shubham Pandey. What is happen if you put your workpiece at Rx or just below the Rx? Are you getting stress relief taken place? Yes, 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 yes. Now let's move to the next question. Yes. In an open die forging, a circular disc is gradually compressed between two flat platons. It's a plate, two flat die. Basically, it is a two flat die. Okay, two flat dies. The exponential decay of normal stresses on the flat face of the disc from the center of the disc towards its periphery indicate that. To the periphery indicate that. It's a very good question. Believe me, it's a very good question. If you are A, only sliding friction is present. A person is saying, sir, option A is the right one. Sir, option A is the right one. Sir, option A is the right one. What about other? My dear? Shubham Pandey says, sir, A, only sliding friction is present. Sir, he says, only A, sliding friction is present. I am going to repeat this question again. In an open die forging, a circular disc is gradually compressed between two flat die. The exponential decay of normal stress on the flat face of the disc, either you can take what? Either if you are suppose that compressing a disc, if you are compressing a disc or a slab, if you are compressing a slab or if you are compressing a disc from the center of the disc or slab, suppose that if I am putting slab towards its periphery indicate that exponential decay. What indicate that? Okay, I am going to discuss this question. Suppose that if you take basically this question comes from open die analysis, open die forging analysis. Are you listening? Sir, in Hindi please. My dear student, gym attitude short. My dear student, the Abhyas batch is purely in English. That's why I have to take that Abhyas batch in English. If you want to attend a Hindi session, please go through the crash course. Crash course will be in Hindi. Okay. Now, my dear student, I am discussing open die forging. Suppose that initially I have a slab, or you can say a disc. Suppose that I have a slab, or you can say a circular disc, a circular cylinder. Okay, a circular disc initially. Suppose that like that, if you have an initially disc, the initial length of the slab is what? Let's say capital 2L. The initial width of the slab, let's say B. Right. Okay, sir, I don't know. Okay, it's okay. Now, in a similar manner, if you take an initial disc, the study is same. Either you see the analysis of this cylinder, or either you see the analysis of slab is same. My dear, is same. Now let's see. Suppose that I'm going to compress this slab in between the die. This is my die. This is a upper die. This is a lower die. This is a upper die. This is the lower die. Right. This is a lower die. Now I'm compressing the workpiece in between the die. Now what are the state of stresses? There will be a chance that in between the die and the surface of the slab and surface of the disc, there will be a chance that in between the surface of the slab and disc, there will be a friction, there will be a sliding, there will be a both. Okay, now let's see. Suppose that this is a slab. Okay, please see, my dear student, please see. Right, please see. This is the slab which I am drawing here. This is a slab which I am drawing here. Please see. This is a slab which I am drawing here. This is a slab which is compressing in between the plate. Which is compressing in between the plate. Like now, this is what at x equal to 0. At x equal to 0. At x equal to 0. Suppose that from x equal to 0, I am considering a strip. I am considering a strip, right? I am considering the strip from x equal to, now see, yes, see, this is what from x equal to 0, I am considering a strip of length dx. Try to understand this thing. Try to understand this thing. This is a very important analysis. Now, this is a strip whose width is what? Whose width is, this is a strip whose width is what? W. Let's say initial width is W. And this is a strip whose length is what? Dx. My dear, if suppose that there is a sliding in between the surface of the slab or disc, in between the surface of the slab and die, or in between the surface of the disc and the die, then what happened? The load per unit area, the load which is acting per unit area is what? The load per unit area is 2k. It is 2k e to the power, please, is it visible? If it is not visible, I will write again. It is what? That load equal to basically 2k, k is the constant, e to the power 2 mu by h. Now what is h? H is the thickness of the slab. 2 mu by h is small l minus x. Suppose that my dear student, suppose that this is the final length. This is the final what? 2l. So half of the length is what? Small l. From x, you have consider a strip of length dx. So the load per unit area which is acting, in which case when there is no friction, when there is sliding between the surface of the slab and die, between the surface of the slab and die, then the load on that strip is what? 2k e to the power 2 mu by h. H is the final thickness. Small l minus x. Small l is the final half length of the slab. My dear, the load per unit area is varying exponentially. The load per unit area is varying exponentially. And what he is asking in the question, he is asking that the load per unit area exponential decay from the normal stress on the flat surface. It means this is a case of what? Sliding. This is a case of what? No friction. This is a case of what? Sliding. This is a case of what? No friction. So what will be the answer, my dear? There is no sticking. There is a no sticking friction anywhere on the flat face of the disc. Are you getting? Suppose that if the stress per unit, if the load per unit area, or if the stress from the center, if the stress from the center to periphery decreases linearly, listen my question carefully. Suppose that stress on the surface of the slab or disc decreases linearly, then which type of case is there? What I am asking, suppose that load per unit area from center to periphery decreases linearly. That load per unit area decreases linearly from center to periphery, then which type of case is there? Is there friction? Yes, very good, Shubham Pandey. There will be a what? There will be a sticking. Let me show you. Let me show you. Let me show you again. Right. Let me show you again. Let me show you again. This is the strip. Suppose that again. Please see. Please see. Please see. This is the again a slab or a circular disc. If you want to take from x equal to 0, right? See, again from x equal to 0, I am considering a strip whose length is dx. Now the load, if the load on this strip, whose width is w, if the load on this strip whose width is w will act 2k plus 2k by h into L minus x. This load per unit area, my dear, this load per unit area, that is what? That is a stress. That is a stress. That stress is decreasing linearly. That stresses decreases linearly, okay, from center to periphery. From center to periphery. Then this is the case of what? Sticking. Here sticking is there. Am I clear? सर गेट वाला पेड बैच में किसी भी क्वेश्चन की फोटो सेंड कर सकते हैं? अरे बिल्कुल कर सकते हैं बेटा, कैसी बात कर दी। अगर समझ नहीं आ रहा हो तो हाँ बिल्कुल श्योर, यू कैन सेंड पेड बैच यार। यस यू कैन सेंड नाउ। एम आई क्लियर? Am I clear? Am I clear or not? Am I clear or not? Yes or no? Tell me. Yes or no? Tell me. Yes or no? Now let's move. Next question. Enrolling of flat strip. Enrolling. अब राजा का बेटा सिर्फ राजा नहीं बनेगा, गरीब का बेटा राजा बनेगा। वाह जी वाह। Now, please, enrolling of a flat strip, the relative velocity of the strip with respect to the roller is what? Enrolling of the flat strip. Yes, beta. Sliding and sticking both ho to? Yes. Anurag Singh, it's a very good question. Sliding and sticking, if both is there, then initially what happened? The stress, Anurag Singh, listen me carefully. Anurag Singh is asking one question. What he asking? Sir, agar if sliding or sticking, if sticking plus sliding both happen, then what is the thing? Now let me explain you. What is a very good question. Again, very good question. Okay, again, very good question. Now see please. See. If sliding and sticking both is going to be happen. Suppose that if sliding and sticking both is going to be happen. See. So what is going to be happen? See here. See. Now, this is x equal to 0. This is x equal to 0. Right. So, from x equal to xs, similarly from here also. from x equal to xs, what is going to be happen, my dear? What is going to be happen, my dear? Basically, initially, sticking will happen first, then the stress is decreases exponentially. Stress is decreases exponentially, right? Stress is decreases exponentially. Stress is decreases exponentially, because initially what happened? Initially sticking happen. If sticking and sliding will occur, then first of all the stress decreases exponentially. This is sticking. This is sticking. Then at a point, at a converting point, that is excess. From that point, the load decreases linearly. The load decreases linearly, my dear student. The load decreases what? The load decreases linearly. Are you getting my point? The load decreases linearly, right? The load decreases linearly. The load decreases linearly. The load decreases linearly. So this is what? This is what? This is, my dear, this is a case of sticking. Sticking. This is a case of what? Sticking. This is a case of what? Sticking. This is a case of sticking. Are you getting? Are you getting your point? Are you getting, Anurag Singh, what you ask? Sir, if sticking and sliding both happen, then stress decreases first exponentially, then after some point it decreases linearly. Then it decreases linearly. Is that clear? Is that clear? Okay. Okay. Let's move to the next question. Now, in rolling of a flat strip, the relative velocity of the strip. Tell me the answer. It's a question number 3. Tell me the answer. It's a question number 3. In rolling of a flat strip, the relative velocity of the strip with respect to the roller is positive at entry plane, negative at the exit, negative at the entry plane, positive at the exit. What will be your answer? Positive throughout from the entry to exit plane. D. Negative throw from entry to exit plane. Yes. Tell me re baba, tell me. What will be your answer? Your answer is what? Somebody says A. Somebody says B. Okay. A, B, A, B. Okay. B is coming consistently. Only one student says B. Only one student says A. Okay. B. Sir, note कहाँ से मिलेगा? The note will the notes you can access from PW app. You can access from PW app, right? Engineers Pushpendra, you can access from PW app. Okay, shall I explain this? Yes, the correct answer is B. The correct answer is B, not A. Not A. Let me explain you. Let me explain you, my dear student. Suppose that you are doing a rolling operation. See here. Suppose that we are doing a rolling operation. This is a roller. This is a roller. This is a roller. This is the workpiece. Okay. Suppose the workpiece is entering with velocity what? V0, and the roller is rotating with a omega angular velocity. Okay. Now the workpiece will be come out. The workpiece will be come out what? The workpiece will be come out with a final velocity what? V final. Are you getting? Are you getting? Now what happened? If the roller is rotating, if the roller is rotating with angular velocity omega, then you know that the tangential velocity, that is the velocity of roller, is what? Suppose that this is the radius of the roller, so it is r omega, right? At each and every point, velocity of roller, at each and every point, velocity of roller is what? R V equal to velocity of roller is what? R V R omega. Now, my dear student, what happened? Initial velocity of workpiece is less than velocity of what? Roller. Once it's come in a contact with roller, once the workpiece comes in a contact with roller, what happened? Friction comes. What happened? Friction comes what happened, my dear student? Friction comes on the surface of the workpiece. On the surface of the workpiece. Friction come on the surface of the workpiece. Because of the friction, the velocity of workpiece is increases. And at the exit, the velocity of the workpiece is what? High. So initially, velocity of workpiece is what? Less than what? Roller. So it is negative with respect to that. And exit velocity of workpiece is higher than velocity of roller. So it is positive with respect to roller. Yes or no? Yes or no रे? समझ में आया? Are you getting the point? Yes or no? Because of friction, the velocity of the workpiece is increases at each and every point, and at the end, velocity of workpiece become VF. That is the highest velocity. Okay, that is the highest velocity of the workpiece. Why it is increasing? Because friction acting continuously on the workpiece. Because workpiece and roller are in contact. Is that clear? Ray? Tell me, is that clear? Yes or no? Meanwhile, what happened? What happened? A point will become. A point will become velocity of roller increase, velocity of workpiece increases. And at some point, velocity of workpiece become equal to velocity of roller. That point is known as what? Neutral point. Okay, neutral point. That point is known as neutral point. And through that neutral point, a neutral plane passes. Yes or no, re baba? Yes or no? So at neutral point, velocity of the roller is equal to velocity of the workpiece equal to velocity of roller. After that point, velocity of workpiece increases, and it is greater than velocity of roller and input velocity of the workpiece. Am I clear? Velocity increases due to volume constancy, sir. Friction is a negative after. Yes, the direction of it changes, but because of friction, the velocity is going to be what? Increases. Yaad ho gaya re baba? Yaad ho gaya na? Okay, now let's move. Now the next question. So answer is what? Answer is B. Negative at the entry plane, because initial velocity is less than velocity of roller. So if you find V0 minus VR, it comes what? Negative. And velocity of workpiece at the exit is greater than velocity of roller. So velocity of workpiece at the exit is greater than velocity of roller. So it is what? Positive. So B is the correct answer. सर प्लीज एक सेशन यूट्यूब गेट पेड बैच में डाउट सॉल्विंग के लिए ऊपर श्योर सूर्य कुमार वी आर गोइंग टू टेक ऑल द बैचेस डोंट वरी सर व्हाट इज अ बैकवर्ड स्लिपिंग एंड फॉरवर्ड स्लिपिंग फॉरवर्ड स्लिपिंग आई विल एक्सप्लेन लेटर otherwise what happened, the remaining question we are not going to solve, my dear. Okay, let's stick to the question. There are a lot of things to discuss with you. Now this is the question, my dear. Yes, try. This is a question, my dear. Try. What question says? Sir, notes नहीं मिल रहे हैं. My dear, notes are available. There is one session on YouTube. You can search. There is a session on YouTube. How can you get notes from PW? Okay, there is a session on YouTube. How can you get notes? Okay, on PW app. There is a session. You can see that session. Easily you will get. Sir, production आज start ही हुआ है कि काफी पढ़ा दिया. बेटा I'm only discussing what? I'm only discussing some good problems. That's it. Okay. I'm only discussing some problems. Right. From 9 p.m. to 11 p.m. So this sir is taking production, theoretical production, theoretical part. Here I am discussing only a numerical portion. Right. This is Abhyas batch. As you know, in Abhyas batch we are only solving some good problems, and there is another course, that is a crash course, which is going to be taken by Dr. Sudesh Singh sir. He is going to deal the crash course of the production. In that course you can understand the theory, right? Now tell me the answer. Tell me the answer. Tell me the answer. 80 mm thick steel plate. Okay, thick steel plate. H0 is there. 80 mm with 400 mm width is rolled. The width of the plate is what? 400 mm. 400 mm. Okay. It is decreases to 40 mm. That is the final. 40 mm. In how many pass? 4 pass. Number of pass? 4 passes. With equal reduction in each pass. Means you are doing number of reduction. Means you are doing number of reduction. Okay, by using rolls of 800 mm diameter, it means the diameter of the roller is 400 mm. 400 mm. Right, assuming the plane strain deformation, assuming the plane strain deformation, what is the minimum coefficient of friction? My dear, you have to find what? You have to find coefficient of friction. Right. Now, here number of passes are given. This is a delta H required divided by delta H maximum. Am I clear? Delta H maximum. So delta H maximum equal to delta H required divided by number of passes. So delta H required, my dear, delta H required, that is what? H0 minus H final. H0 is what? 800, oh sorry, H0 is what? 80 and H final is 40. So 80 minus 40 is what? 80 minus 40 is what? Again 40. Number of passes are what? 4. So delta H max equal to what? 10. Am I clear? Delta H max equal to what? 10. This is a delta H max. Now, my dear, you also know that delta H max equal to mu square into R, and delta H max is what? 10 mm mu square. R is what? Radius of the roller, that is what? 400 mm, right? So mu is what? 10 by 400 to the power 1 by 2. Am I clear? To the power 1 by 2. Recorded lecture to mil jana. Okay. So 10 divided by 400 to the power 1 by 2. So it is coming 0. So mu is coming 0.158. So 0.158. Option B is the correct answer. Option B is the correct answer. Option B is the correct answer. Are you getting the thing? 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 Is that clear? Is that clear? Is that clear? Okay. Now let's move. Let's move to the next question. Now let's move to the next question. Okay. So this is the Next question. It's again very beautiful question. Again very beautiful question, my dear. Again very beautiful question. It's a very important question even. It is a very important question. Okay. It's okay, yaar. Ashwin, it's okay. Ashwin Verma, it's okay. If anybody say something, then allow them, na yaar. Allow them. Don't mind their language. Even I don't mind. Even I don't mind. Even I don't mind, okay? So, it is good that you should concentrate on that board. Look, people are giving some negative thing to you. If people are commenting negative thing to you, it proves that you are doing good. If people are giving a negative comments on you, it means you are doing something. It means you are doing something. Okay? So don't mind. Whatever people say, don't mind. Even I don't mind. What do people say? Just do your work. That is a more important thing. Okay? Just do your work. This is a more important thing. Don't mind what the people are saying. Yes. Yes, please solve this question. It is an NET type question. Again, it's a very good question. Again, it's a very good question. Yes. Again, it's a very good question. Again, it's a very good question. Just apply your mind. It's a conceptual question. It's a conceptual question. Just apply your mind. Yes. Yes, please solve this question. Solve this question. What he says. What he says. What he says. He says that the maximum reduction per pass during the wire drawing of an alloy, okay, is what? Of an alloy, ignoring friction and reduction, work is 77%. This is the main thing. The maximum reduction per pass during the wire drawing of an alloy or aluminium, what? 77%. My dear, it is given that maximum reduction. Please see the thing. Please see the thing. Please see the thing. Please see the thing. Okay, please see the thing. It is given that maximum reduction per pass, okay, per pass, the maximum reduction in per pass, redundant work is redundant work is how much? It is 77%. Per pass, it is what? It is 77%. Am I clear? Now, you have to find what? Strain hardening exponent. You have to find strain hardening exponent. That is what? That is your N. You have to find the N. Okay. My dear student, please see. My dear student, please see one thing. Please see. Right. In ideal deformation of strain, in ideal deformation, in ideal deformation, in ideal deformation of strain hardening of strain hardening material, strain hardening material. My dear, there are two things. What are the things? We know from two stress and true strain curve, from two stress and two strain curve, that is the stress equal to k stress equal to k e to the power n, from true stress and true strain curve, and true strain curve, am I right? Also from average stress, that is what, k e to the power n divide by 1 n plus 1. My dear, when the maximum reduction is going to happen, in that case your two stress and your average become equal. Your two stress and average become what? And average become equal. Your two stress and average stress become what? Equal. Your two stress and average stress become what? Equal. If that thing, then it means, if that thing, oh sorry, yes, if that is the thing, my dear student, if that is the thing, then what? If your sigma two stress equal to sigma average, then you can write k e to the power n equal to k e to the power, okay, k e to the power n divided by 1 plus n or n plus 1. Is that clear? Maximum reduction occur, right? Why I am writing this? Again I am going to write maximum reduction occur when drawing stress is equal to, my dear, maximum stress. Why I am writing? Because what he say maximum reduction occur, because he say maximum reduction occur. Whenever the maximum reduction occur, then true stress, in that case the true stress equal to what? Your average stress. Your true stress will become equal to what? Your average stress. Is that clear? Now k is going to be cancelled. Now you have to solve this thing. Okay, now you have to what? Solve this thing. Am I clear? Yes or no? Tell me. By using that concept, you can solve this question. Is that clear? Yes. What is your answer? Rushikesh says that answer is what? 0. No, my dear, it's a 0.46. Answer is what? N is what? 0.46. The answer is what? 0.46. 0.46. The answer is beta. Yes, 0.46. Shubham Pandey, you are right. 0.46. It means you can solve. It means you can do the calculation. So I am leaving the calculation on you. Right. I am leaving the calculation on you, and I am moving to forward, and I'm moving forward. I'm moving forward, right? I'm moving forward. Basically, this is a concept. This is a two stress strain curve. Okay, and this is the average flow stress. Okay, now let's move to the next question. Let's move to the next question. Yes, again, it's a very good question. Again, the question is good. Again, the question is good. Yes. Yes. Tell me. In a single pass rolling operation, 200 mm width, 200 mm width metal strip is rolled from a thickness of 10 mm to the thickness of 6 mm. The roll diameter, the roll radius is what? 100 mm, and it rotates at 200 rpm. 200 rpm. The roll strip contact length is a function of roll radius, okay, and the initial final thickness. Okay, it is a not so much important of the strip. If the average flow stress in a plane strain of the strip of the material is what? 500 megapascal, the roll separating force. It's a very easy question. It's a very easy question, in fact, not a very tough. It's a very easy question. It's a very easy question. Yes. सर 8 अक्टूबर आप पेड बैच में डाउट इंजन के ऊपर एक क्वेश्चन सेशन ला रहे हो ना? My dear, there are a lot of sessions which are in pipeline, so don't worry. Lot of thing will become. You just concentrate. Yes, because if most of the people, yes, you are right, most of the people are able to solve the question, then why we are going to waste the time? It's better that we should give more time to the other question. It is better that we should give more time to the concept. If you people mostly all of them have given the right answer, that is a 0.46, then why should we take our time, my dear? It is better that I can give that time to your query. It is better that I can give more time to the next question. It is better that I can give the more concept in that time. Yes. That question was easy, damn easy, and you people have given the correct answer. Right? You people have given the right answer, and I believe you. Okay. Yes, next question. In a single pass rolling operation, 200 Newton. Okay, now from onwards, I will give, when a question is simple, I will give the each and every solution. Don't worry. Right? If the question is simple, I will give the solution of each and every one. Right? Okay. Now, if you people want me to the solution of the easy one, then I will give. No need to worry. Okay, what we have to find? The roll separation force. What is the roll separation force? Tell me. What is the roll separation force? The average stress into width of the workpiece into what? Into the length of contact. Yes or no? Yes or no? Yes or no? Okay. Now you have to find what? The length of the strip. The length of the strip is what? The length of the strip is what? The length of the strip. The length of the strip, that is root R delta H. Root R delta H. R is what? A single pass rolling operation, 200 mm white. Metal strip rolled from a thickness 10 mm to what? 6 mm. So delta H is what? 4. And 200 mm white. What is the radius? The roll radius is what? 100. The roll radius is 100. It is again very easy one question. It's again only thing here to calculate the projectile length. Yes, again it's a very easy question. Okay, again it's a very easy question, but if I skip the question, again the people will say, sir, you skip the calculation. Huh? You people say that, sir, you skip the calculation. Okay, then in that case I will solve, so that you people don't say that, sir, you are skipping the calculation. You are skipping the calculation, right? So my dear, from now onward, if the question is easy or tough, don't worry, I'm going to give each and every solution. I give each and every solution. So that is the L, and the roll separating force is what? 500 megapascal. Width is what? 200. Width is what? 200 mm wide into L. L is what? 20. So 20 into 200 into 500. Answer divide by 1000. So 2000 kilo Newton. Right? 2000 kilo Newton. Again the question was easy, but if suppose that if I was skip that calculation, that you people say, sir, you skip the calculation. Okay. Next. Solve please. Solve please. Solve please. What the question says? A 100 mm long cylinder. First of all, I will explain the question. A 100 mm long cylinder, workpiece of a diameter 50. Workpiece of a diameter 50 mm is reduced to 25 mm. Okay. 100 mm diameter is reduced to 25 mm diameter using the extrusion process. Okay. So here D naught is what? D naught is 50. D naught is 50. And D final is what? D final is 25. D final is what? 25 mm. During extrusion process. During extrusion process. Right. Okay. Using the flow curve for the metal has a strength coefficient K. The K is given. The K is given. K is what? 750 megapascal. Okay. And the strain hardening coefficient, that is N. The strain hardening coefficient, that is what? That is N. N is what? 0.15. Assuming no friction and no reduction work, the required ram pressure in megapascal. The required ram pressure in megapascal. The required ram pressure in megapascal. Now I have given all the data, all the common data. Okay, all the given data I have written there. All the given data. This is a given data. So I make it very easy. You have to find the required ram pressure. Yes, tell me the answer. Yes, tell me the answer. Now let's see how many of you them are going to solve this question. Now let's see how many of you them are going to solve this question. My dear, you know now, this pressure is what? This pressure is what? Sigma naught, that is the average flow stress. That is the average flow stress, ln initial cross section area divided by final cross section area. Yes. Find out the answer. Let's see who is going to solve this question. Yes, somebody says, Suraj Pandit says 950, option D. Suraj Pandit say, sir, it's option D. Now, shall I solve this question? Otherwise, what happened? People say, sir, you skip the calculation. Okay. My dear, what do you need? This is the average stress. As you know now, this is what? This is the average stress. How can you find the average stress? The average stress is what? K e to the power n divided by 1 plus n. Here n is given and k is given. K is what? 750 megapascal, n is 0.15 megapascal. Right? So the average stress. So the average stress is what? Average stress, right? You need to find that average stress, K. Now for that you have to find the strain also. You have to find the strain. What is the strain? ln A naught by A final, if I am not wrong. ln A naught by A final, if I am not wrong. So find out the strain. Find out the strain. Strain, that is ln A naught by A final. Right? A naught by A final. A naught by A final. Right? A naught by A final. So strain, again the strain is ln A naught, that is what? Pi by 4 d naught square divided by pi by 4 d final square. So this is cancel. It comes out. Yes. So yes. So the strain is 2 comes out here, ln d naught by d final. So twice of ln d naught by d final. So d naught by d final is what? 50 by 25. 50 by 25. So it is 50 by 25. Now calculate the strain. The strain will be twice of ln. The strain will be ln of what? ln of 50 by 25. Answer into 2. It comes 1 point. It comes 1.386. This is a strain. Now this is a strain. Now find out the average strain. Find out the average stress. Find out the average stress. The average stress is K, that is 750 megapascal, E 1.386 to the power n. And what is the value of n? That is 0.15 divided by 1 plus N, that is 0.15. Am I clear, my dear student? Okay, so 750 into 1.386 to the power 0.15, answer divided by 1 plus 0.15, so it comes 680, right? It comes 680. It comes average stress. Here average stress come, here average stress come what? 684.9 megapascal. Am I clear? Am I clear? Am I clear? 684.9 megapascal. Now, you know that we need to find the P, that is sigma naught ln A naught by A final. Now you have the value of average stress. So you can write here, it is what? It is P and sigma naught 684.9 ln A naught, even you can write what? Ln, that is a pi by 4 d naught square divided by pi by 4 d final square, right? So P is what? 684.9 into 2 ln d naught, that is what? 50, and d final, that is what? 25. So answer into 2 into L, sorry, it's a ln into ln 50 divided by 25, so it comes 9, it comes P equal to 949.47 megapascal. So approximated you can write that 950 megapascal. So anybody has any doubt? Anybody has any doubt? Anybody has any doubt? My answer is coming 949 and your is coming 947. My dear student Molly Gunturu, your answer is 947 and mine is 949. I mean 2 megapascal difference is there. 2 megapascal difference is there, my dear. 2 megapascal. Your answer is what? Molly, M-O-U-L-I. If you are listening me, M-O-U-L-I. Molly, your answer is what? P equal to 947 point what? 0.27 megapascal. So there is what? There is a difference of what? 2 megapascal. Difference of 2 megapascal. So you have done some mistake. Molly, are you typing mistake, sir? Okay. If the typing mistake is there, then it's okay. Then it's okay. Everybody understood the process? Everybody understood the process? Everybody understood the process? Yes or no, my dear? Please tell me. Yes or no, my dear? Please tell me. Shall I move to the next question? Shall I move to the next question? Yes or no? Please tell me. Shall I move to the next question? Shall I move to the next question? Yes. Okay. Sir, 10th October को कौन सा subject start हो रहा है? बेटा see the timetable ना. You will get all the idea. We have uploaded all the timetable. Okay. Even Vikas, Vaibhav, we have taken the session also. In that session, we have mentioned each and every subject along with the teacher. Right? So see that session. Please see this question. What the question says? A cylindrical billet of what? A cylindrical billet 90 mm diameter is extruded to produce I section. This is I section as shown in figure. This is the product. This is the product, right? So this is the product you are getting as shown in figure. All dimension in mm. Please note down because the remaining question in on the next slide. Please note down this thing because the remaining question is on the next slide. Please note down because the remaining question is on the next slide. Please note down the data. The cylindrical billet of what? 90 mm. The cylindrical billet of what? 90 mm. Please note down, my dear. Please note down because the remaining question is on the next slide. Because the remaining question is on the next slide. Please note down. Please note down. Cylindrical billet of 90 mm diameter. right? And this is the product. My dear, this is the product. This is the product. This is the product which you obtain after extrusion. Write down. Write down, please. This is the I section. सर 10 अक्टूबर को कौन सा सब्जेक्ट से स्टार्ट हो रहा है पेट बुआ? Yes, please note down. Don't worry, Vikas Vaibhav. Each and every subject, each and every subject expert, you know, will feel you motivated. So don't worry. Yes, my dear. Have you noted down? Have you noted? Have you noted? Okay, done. 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 Now, the total extrusion pressure is PE. The total extrusion pressure is what? PE in megapascal required. For the above process given by PE, PE is what? Sigma M into 0.8 plus 1.2 ln A naught by A final. Where sigma M is what? Sigma M is the mean flow stress of the material, and A naught, A final are the initial and final cross section area. If the mean flow stress of the extruded material, that is sigma M, 80 megapascal, the force required for the above extrusion in kilonewton is, you need to find the force. You need to find the force. Yes, you need to find the force. You need to find the force. Find out the force. A naught is what? The initial cross section area, right? If I am not wrong. Here, A naught is what? Initial cross section area. A naught is the initial cross section area of the billet. That is pi by 4 d square. That is 90 square. Because 90 is given, I think. Please see the data. Initial billet cross section area is what? 90. Right? Initial. A naught is given. So it is shift. It is what? Shift pi by 4 into 90 square. It is 6361.72, right, mm square. Now, final cross section area. My dear, you need a what? Final cross section area. So, we need a final cross section area. This is the final one. So, the final cross section area is what? This is a rectangle. See please. So 50 into 5 plus. Again this is this cross section area, that is 60 into 5 plus 50 into 5 again. 50 into 5. So what will be the final cross section area? The final cross section area is 50 into 5 answer plus 60 into 5, that is 800 mm square. 800 mm square, right? Right? So this is the 800 mm square. Okay then. So you know that A final is what? A final is what? 800 mm square. Now what you need to know? You need a load. Okay, here the value of load is what? Here the value of load is what? Okay, let me write down PE. That is what? That is the value of the extruded pressure. Sigma m is what? 80 megapascal, right? Into 0.8 plus 1.2 into ln A naught is what? 6361.72 divided by what? 800, right? So you will get what? PE. You will get what? PE. You will get what? PE. So PE is what, my dear? It is the ln of 6361.72 divided by answer into 1.2, answer plus 0.8, answer into 80, that is 260. That is what? That is 263.05 megapascal. But you need what? You need a load, right? You need a load. Am I right? Up to here, I think there will be a no doubt. I think there will be a no doubt. Now what you need, my dear? You need the value of force. So my dear, how can you find the value of force? The force is that is F equal to PE into A naught, and PE is what? You get the value of PE, that is 263.05 into A naught. A naught is 6361.72, right? So here 263.05 into 361.72, you will get in kilonewton. In kilonewton it will comes. In kilonewton it will come 4 equal to 1673.45, because you have to round off. Up to 2 decimal place. So up to 0.45 is sufficient. It is kilonewton. Anybody has any doubt? Otherwise you people say, sir, you skip the calculation. 1673. Otherwise what you do? You people say, sir, you skip the calculation. Even the question is very easy. Even you are not capable to do any calculation. Hai na? Right? Okay. Is the answer is clear? Is the concept is clear? Anybody has any doubt? Anybody has any doubt? Anybody has any doubt? Yes, please. You can ask if you have any doubt so that I can move. Otherwise, I can move on to the next question. Anybody? Tell me, my dear student, is there any doubt, or shall I move to next question? Yes. Okay, now let's move to the next question. Yes. Next question. Even though the question is very lengthy, but don't worry. Read the question very carefully and very calmly. You will get your answer. Read the question very carefully and calmly. You will get your answer. A wire of 5 mm diameter is drawn into a wire of 4 mm diameter through a conical dia at a constant pulling speed of what? 5 meter per second. Okay, I mean you are pulling the wire with a speed of 5 meter per second, neglecting the coefficient of friction and redundant work. The drawing stress sigma d in megapascal for the above process is given by sigma d. Drawing stress sigma bar, I think it will be the average. Look, it is the average. It is given in the question that sigma bar is what? Mean flow stress. mean flow strength of the wire material in megapascal. 1 by 1 minus R. R is what? R is the ratio of decrease in area of cross section to initial area of the wire. Means I think it will be a delta A divided by A naught. I think it will be a delta A divided by what? A naught. If the mean flow strength of the wire material is, okay, if the mean flow stress of the wire material is 600 megapascal, then the power required in kilowatt above the wire drawing process is, okay. Have you noted? Somebody says, sir, it will be 168.1 kilonewton kilowatt, sorry, and some Rushikesh says 16.824. Dear, there will be a difference, lot of difference. There will be a lot of difference. There will be a lot of difference. 16.8 or 16 point, okay. Now Suraj Pandit says 168. Dear, okay, Suraj Pandit, by mistake. Okay, it's okay. 16.81, right. Only 2 students has given the answer, Rushikesh and Suraj Pandit. What about others? What about others? Shall I solve this question? Okay, without wasting our time, I am going to solve this question. Without wasting our time, I am going to solve this question. See here. Arey Baba. What is happening? Okay, leave it. Okay, so in a wire drawing, it is given that sigma D equal to sigma bar ln, okay, 1 by 1 minus R. This is given na? Okay. The important thing you have to, what is happening? I think some technical issue. Okay. Just a minute. Okay. See. So it is given. Okay. And R is what? R is that is delta A divided by A naught, right? Delta A divided by A naught. Delta A is what? That is your final. A naught, that is what? A naught minus A final divided by A naught, and it will be 1 minus A final by A naught, right? 1 minus A final by A naught. Dear, suppose that if I am going to change, this thing, if I will write that A final divided by A naught equal to 1 minus what? R, right? Okay, then I can also write then 1 by 1 minus R equal to what? A naught by A final. My dear, 1 by 1 minus R equal to A naught by what? A final. Am I right? Now you can write that sigma D equal to sigma bar ln A naught by A final. If I am not wrong, right? Now here in this question, see, in this question sigma bar is given, right? Sigma bar is given. So drawing stress. So the drawing stress, that is what? sigma d. Sigma bar is what? 600 into ln a naught. A naught, that is what? A naught. See, via diameter. A naught, that is a 5 meter, 5 mm and 4 mm. Right? 5 mm and 4 mm. So pi by 4 d naught square divide by pi by 4 d final square. So pi by 4 cancel. So drawing stress will be what? 600 into twice of into what? ln of 5 by d naught is what? And d final is what? 4. So you will get what? Drawing stress. You will get drawing stress, and drawing stress will be, that is 600 into 2 into ln 5 by 4. So it will become 267.77, okay, 2 megapascal. So it will be the drawing stress. But we have to find, okay, what? We have to find the power required. So what will be the power required? The power will be drawing stress into what? Into the final cross section area, because you are applying the force on the final cross section area. This is the drawing force, multiply into drawing velocity. Multiply into what? Drawing velocity. Okay. So the drawing stress, so here the drawing stress is 267.772. Okay. My dear, remember one thing. It is in Newton. It is in Newton per mm square. Megapascal. What is a megapascal meaning? Megapascal is Newton per mm square. Am I right or wrong? Newton plus mm square. Right. Now here Newton per mm square. I mean, this is Newton per mm square. A final is what? Pi by 4 d naught. That is what? 5 square. So it is again in mm square. So mm square will cancel. So velocity is in meter per second. So there is no space. That's why I'm not writing the value of velocity. So here the power is 267.772 into pi by 4 5 square into velocity. What is the value of velocity? The value of velocity 5 meter per second. 5 meter per second into 5 meter per second. So Newton meter per second, right? So Newton meter per second. So what is the answer? Answer into shift pi into 5 square, okay, into 5, answer divided by 4, answer, okay, answer divided by 1000, answer divided by pi by 4. Oh, sorry. 5 is not. 5 is the initial now. By mistake I have written. By mistake. Sorry. It's a by mistake. Not 5. It is a 4. It is the 4. Right? It is a 4. 4 square. Right? It is the 4 square. Now, it is a 4 square. So, if you do 4 square, let me do the calculation again. 267.772 into shift pi into 4 square, okay, into 5, answer divided by 4, answer divided by 1000. Now 16.8. Now the power is coming 16.824 kilowatt. How many of you them are getting this answer? How many? Yes, sir, 4 का square होगा. Yes. By mistake, I have written final cross section area. I have written here final cross section area, but by mistake I have written what? Initial diameter. Right. So this sometime typing mistake will be happen because I'm explaining the thing also. I'm writing the thing also. Meanwhile, I'm communicating to you also. So sometime the mistake will be happen. Okay. So anybody has any doubt regarding this question? Anybody has any doubt regarding this question? Yes, tell me. Yes, tell me. Or shall we move to the another question? Shall we move to the another question? Yes or no? Yes or no? Tell me. Tell me. Shall we move to the another question? Yes or no? Shall we move to the another question? Yes. Shall we move? Okay. I hope you don't have any problem. Now this is the last question of today's session. Last question. Last one. Try this. Try this. Decrease in area by initial area. What do you say? Is anything wrong in this question? 3.5 mm thick sheet is rolled using two high rolling mill to reduce the thickness under a plane strain condition. I mean that 3.5 is going to reduce. That 3.5 mm is going to reduce to the final thickness what? H final. Under a plane strain condition, both rolls have a diameter. Roller diameter are given. Roller diameter are what? 500 mm. 500 mm. And rotating and omega angular velocity. Angular velocity is given. Okay, 200 RPM. Revolution per minute. RPM is given. 200 RPM. The coefficient of friction at the sheet and roll interface, that is what? Mu. Mu is given 0.08, and the elastic deflection of the roll is negligible if the mean flow strength of the sheet material is, if the mean flow stress of the sheet material is 400 megapascal, then the minimum possible thickness of sheet can, can produce, means that H final you have to find that minimum in one single pass. In one single pass you have to find. In one single pass. Okay, if you are talking about in one single pass, then maximum reduction delta H max equal to what? H naught minus H final, and that H final is what? Minimum. That H final is what? Minimum. That's why that delta H will be maximum. Now the delta H maximum is what? That delta H maximum will comes, that delta H maximum will come mu square R, and mu is given, that is 0.08. 0.08 square into what? Roller radius, that is 500. Okay, so that is a delta H max. So this is a delta H max, that is 0.08 square into roller radius. Let me see, it is a roller radius 500. Oh sorry, it's a diameter. Okay, it's a diameter, right? So the radius will be what? Radius will be 250. Okay, on the next slide I will write. Roller diameter is 500. I have written the radius by mistake, right? So here delta H. So delta H, that is 0.08 square into R. Okay, into R, that is what? 250, because diameter is what? Diameter is 500, right? Diameter is 500. H naught is what? 3.5, that is 3.5. This is H naught, 3.5 minus H final minimum. H final minimum, right? So H final minimum equal to 3.5 minus 0.08 square into 250. It will become in mm. It will become in mm. So what will be the value? You are saying 1.9. I am also going to calculate whether we are getting or not. 3.5 minus 0.08 square into 250. It will become 1.9. Delta H, sorry, it is a H. It is a H final. H final minimum is what? 1.9 mm. Right? Right? Clear? So my dear, tomorrow session, in tomorrow we are going to discuss what? We are going to discuss casting and welding. Casting and welding. Casting and welding problem. So please, casting and welding problems. So please revise the thing. Right, please revise the thing. Stress should be maximum when we calculate. Okay, so please revise the thing. Yes, what you are saying? Stress. If the mean flow stress, are you talking about this? Are you talking about this? Are you talking about this? Actually, in the question, he is misguiding you, giving unnecessary data. In the question, he is misguiding you by giving unnecessary data like this. I mean, there is no use of this sigma bar. He wants to know minimum possible thickness of sheet. Minimum possible thickness of sheet that can be produced in a single pass. For that, we know that delta H max equal to mu square R when we calculate for maximum reduction. My dear, when we calculate the maximum reduction, that's why I am saying, my dear, when you are calculating the maximum reduction, the maximum reduction is what? The maximum reduction is what? This delta H max. This delta H max. How can you get that delta H max? Tell me, how can you get when we calculate maximum? But ये formula average क्या लिए मत है? अरे sir, this question enough for gate 2000. Look, when you are talking about delta H max, it means H naught minus H final. That H final must be what? That H final must be what? Tell me. That H final must be what? Should be minimum, na? That H final must be what? Should be minimum, na? That H final should be what? Should be minimum, na? If this is minimum, then the delta H will be maximum. And for delta H maximum, you know that it is mu square R. It is mu square R. It is mu square R. Yes or no? Yes or no? Okay. Okay, then tomorrow we are going to meet. Revise your casting and welding. We are going to solve the problems on casting and welding, right? So that's it for today's session. Thank you for watching this session. As you know, from 4 p.m. Tom, theory of machine, right? Tom, theory of machine. That is a gear and gear train, I think. Gear and gear train is going to be taken by Vishwajit sir. Okay? Is going to be taken by Vishwajit sir. Okay? So that's it for today's session. Thank you for watching this session.